All right, so for this problem, we are looking at the quadratic function. Tell me this. How do we know that this function is quadratic?
The highest exponent is 2.
It has the highest exponent of what? 2. Very good. And what form is this function in? Standard form. What is the standard form of a quadratic function?
Y equals a squared plus
Okay. Again, y equals
a squared
y equals ax squared plus bx plus c. What does standard form give me? It give me my a, b, and my what? C. Okay, so let's talk about the a. What does the a give us in our standard form?
Concavity.
It gives us concavity. How does it help me figure out concavity?
If it goes up or down.
If it use up or if it use what? Down. That is based on the A being what? Positive or negative. So if the A is positive, then it use up, which means I have a minimum. If the A is negative, it use down, which means I have a maximum. Very good. Let me ask you this. What if we were talking about the range of the function? Right? And let's say it use up. Not the domain. What is always going to be the domain in this case? All real numbers. But I'm talking about the range. So what if I'm talking about the y's, right? So what if I had it uing up and I had a minimum? Give me the first two parts of my range. It would be y is what? Greater than or equal to whatever that minimum is. Are y'all with me? What if it u down? Y is less than or equal to. Very good. Excellent. All right. So standard form gives us our A, which talks about our concavity. Positive use up minimum. A negative use down. We have a maximum, right? And then B doesn't tell us our shift. It tells us if we have a shift. Are y'all with me? Yes. If you have a B, and what is the B in this case?
Negative 15.
Negative 15. If you have a B, then that means you have a shift. Now, how can I use that B to help me determine which way it shifted? What do I have to do?
Negative.
You gotta multiply what? A and B. Come on, we keep going back to this, right? A, B. In your notes. If you don't have it right now in your notes, let's write it down. I want you to see it as many times as you can. A, B. What does AB mean?
A times B.
A times B. If A times B is positive, which way does this thing shift?
To the left.
To the left. If A times B is negative, which way does it shift?
To the right.
To the right. I need you to know that. If I give you a function in standard form, you cannot tell me which way it shifts just by looking at the B alone. The B tells me there was a shift. But in order to figure out which way it shifted, if it shifted left or right, your horizontal shift, you have to look at A times B. If A times B is positive, that means that vertex shifted to the left of the y-axis. If A times B is negative, that means that vertex shifted to the right of the y-axis. Are y'all following me? Yes. Now, if we look at this, give me my A, B, and C for this function. What's my A? 1. What's my B?
Negative 15.
Negative 15. What's my C?
36.
Positive 36. Now, if I do A times B, will I get a positive or a negative?
Negative.
Negative. So what does that tell me about this function?
Shift to the right.
It shifted to the what? Right. So I know when I see this vertex, it should be to the right of the y-axis. Are y'all with me? Yes. Now, is there another way to figure out the shift other than doing A times B?
Yes.
What is that?
Looking at the A.
Looking at the what? Vertex. Because your vertex gives you what? Horizontal shift. And it gives you your what? Vertical shift. The X of the vertex is our horizontal shift. The Y of the vertex is our vertical shift. It tells us how much we move up and down from the origin. Are y'all with me? All right. Now, let's just move through. Concavity. Talk to me about that. Our A is what? 1. Is that positive or negative?
Positive.
So what kind of concavity do we have? It's going to move what? It's U up, right? Which means we're going to have a what? Minimum or a maximum?
Minimum.
We're going to have a minimum. All right? Now, what else can I pull quickly from this? Real quick, what can I pull? My y-intercept, couldn't I? Don't we know that this gives us the y-intercept? What part of this is the y-intercept?
36.
The C, which is the 36. So my y-intercept is what? 36. Those parts are easy for me, right? Standard form quickly gives us the concavity and the y-intercept. It tells us now, are we going to have a shift for this? Is there a shift? Yes, there is a shift. I know there's a shift because we have a B. We got a B. Now, we did A times B and figured out that our shift goes to the what? Right. So we can put here and put what? Right. Is everybody with me? Yes? Does everybody understand how we know it's right? Yes. Okay, now I got to work on this side. Vertical, vertex, axis of symmetry. I can get all of that from my vertex, right? Tell me, what do I need to do in order to find my vertex? What's the first thing you do to find your vertex? Y equals negative B over 2A?
No.
X equals. Very good. So let's look at X equals negative B over what? 2A. Now what is this going to give me? It's going to give me three things. It's going to give me my X of my vertex. Then it's going to give me my axis of symmetry, or my AOS. And then it's going to tell me my horizontal shift. Exactly how much I moved left or right. If that number comes out to be positive, I move to the right. If that number comes out to be negative, it moved to the what? Left. All right, so we got our A, B, and C. Let's plug them in. So X equals negative. Where did that negative come from? Is that from my B? No, that comes from my formula. Are y'all with me? Now I'm going to plug in what came from my B, which is what?
Negative 15.
Negative 15. And I'm going to put that over 2 times 1, which is my A. Are you all following? Yes? Absolutely. Now, if you look up here in the front, on the side, see where it says the algebra playbook on the right? Right up under that, you see where it says vertex? Yes? Sunday, you with me? The one over here, if you look under that, what does it say right next to vertex? What's that first order pair? What is it? That first coordinate. It says what? It is HK. H is the X of your vertex, right? But what does it say right above H?
Negative 2.
Negative B over what? 2A. So that's telling you how to get the X of the vertex. Are y'all with me? Now, whatever Y you get from plugging that X in is going to be the Y of your vertex. Are y'all following? All right, so let's keep going. What do I do at this point? This says negative 15. What do I put behind this? A 1. The imaginary coefficient is a what? 1. So now I got negative times a negative, which is going to give me a what? Positive. And 1 times 15? 15. So this is going to be 15. And then 2 times 1 gives me what? 2. And what's 15 divided by 2?
7.5.
7.5. How do I write that? X equals what?
7.5.
What does this represent? X of my vertex. My axis of symmetry. And my horizontal shift. Now, can you tell me exactly how much the parabola moves to the side? Yes, and how much did it move? To the right, 7.5 units. Is everybody following? Yes. All right. This is my horizontal shift. And it is my X of my vertex. So if I'm asked to find my vertex, I already know one part of it. HK represents our vertex. It is 7.5. Is everybody following?
Yes, ma'am.
Yes? All right. Now, people get here and get stuck. Let's fill in some information here first. Do we know our vertical shift yet? No. Do we know our vertex?
No.
We know the X of our vertex, which is what? 7.5. Do we know our axis of symmetry? Yes. What is that?
7.5.
But how do we write that? X
X
equals what?
7.5.
7.5. You got to put the X equals. That's what lets us know it is that vertical line. Are y'all following? Yes? All right. Now, what do I do after this? I'm at this point, and I still need to find my vertical shift and my axis of symmetry. And my vertex. So what do I do?
Plug in your X.
Plug it in. Every time they give you an X, just plug it into the equation and get your Y. Just do it. No matter what you're trying to find. Just plug that thing back in, right? So I want to show you something. I know you don't have this on your paper, but I want you to write what I'm writing. I want you to put, first of all, the rule was f of x equals what? X squared?
X squared minus 15x.
Minus 15x plus 36. I want you to do what I'm doing because I want you to see how it's going to be presented to you. They're going to give you this. That is the x. What does that mean? This means, I'm going to tell you exactly what it means. Tell me what it means, sir. Perfect. And when you say what the function equals, what are you talking about specifically? The y. Excellent. Did y'all hear what he said?
Yes.
I'm going to repeat it. He said, what is the y? What do we call this? F of x. But what can we replace it with? Y. Because f of x is what? Y. It's the same thing. So what is this saying? It's saying, what is y when x is 7.5? That's all he's asking you. That's it. Here's what they're giving you. Find this. That's all they're saying. So when they put that there, whenever you see that, whenever you see a function and you see that sitting there in place of x, what are they telling you to do? Plug it in and get the answer. That's it. That's all that means. Y'all hear me?
Yeah.
So what are we going to do? We're going to plug it in. Everywhere we see x, we're going to put what? 7.5. Why? Because you're asking me what is the y when the x is 7.5. So let's plug it in. So here I'm going to put what? 7.5 squared minus
15 times 7.5.
minus 15. Or you can say plus negative 15, but either way it's a minus in the front. Then what? Plus 36. All right, y'all already got this part done, right?
Yes.
All right, so the function of 7.5, meaning what do you get out when you put 7.5 in, right? It's going to be, give me this, 7.5 squared, 56.25 minus, or negative times a positive is negative what?
112.25.
0.25?
Oh yeah,
0.5 plus what?
36.
36. All right, so the function of 7.5 is,
Negative 20.
what we got when you put it all together? What we get? Negative 20.25. Now I want you to look at that for a minute. What is the y when the x is 7.5?
Negative 20.25.
So what do I really have? I have 7.5x, comma, negative 20.25y. That's my y. Does that make sense?
Yes.
Yes? What did we say this is? What does this really mean?
What is
So what can we replace f of x with? Y. So couldn't I just do this?
Yes.
So then it's y equals. Are y'all with me?
Yes, ma'am.
The only reason why we write it this way is because we're telling you what we want your x to be. Are y'all following me?
Yes.
Take that x and just plug it in everywhere you see x. Find your y. That's all that means. It looks crazy, but that's all it means. All right? So what did we just find? Our vertex. What else did we find?
The
The vertical shift, right? So tell me what happened if I have this thing that's sitting on the origin originally. Where did it move to get to its new spot? It moved left.
I mean, down.
Right.
Oh,
What is this?
right. 7.5.
Right, because that's horizontal shift. It moved right what?
7.5.
7.5, and then it did what?
Down.
Down what?
20.25.
20.25. What quadrant did it end up in? Oh, quadrant 1, 2, 3, or 4? 4. This is quadrant 4. This is 3. This is 2. This is 1. How do you remember? It's a C, right? 1, 2, 3, 4. And what is the ordered pair of this quadrant? These are what? Positive. These are what? Negative. So this is the positive what? Negative quadrant. But we know that because this is positive and that is what? Negative. So that makes sense that it fell in that quadrant. Are y'all following? Yes? All right. You good, boo? Yeah? All right. All right, so can we fill out the rest now?
Yes.
All right, so let's go ahead and do that. So what was our vertex?
7.5.
7.5,
Negative
negative 20.25. And then what is our vertical shift?
Negative 20.25.
Negative 20.25, which means it went what? Down. Is everybody following?
Yes, ma'am.
Any questions on this?
No, ma'am.
No. Anything brand new here?
No.
No. We all should be good here, right? All right. So, for the past 3 weeks, we have been working on the key features of quadratic functions, right? We've been graphing them. We've been identifying the different parts. And we've been using them to model real world situations to identify different parts of a problem, right? What we've been talking about is like a vertex. What could vertex give me?
The maximum.
The maximum or the what? Minimum point, right? The highest point or the lowest point, right? It can tell me how long it took to get to that highest point, right? If vertex is here, then what do these 2 points represent on this x-axis?
That's like where it falls.
It's where it falls. It's where it hits what?
The ground.
The ground, right? How do I know that? Because they are sitting on what in math? You gave me ground for real world context, but what is it in math? They're sitting on the x-axis because they are my what? X-intercepts. And what do x-intercepts always have in them for the y? Zero. So if you're talking about height from the ground and the y is 0, what's the height? The height is 0, which means it's where? On the ground. That's why those are called your zeros. Are y'all with me? Or your roots coming out the ground, right? Or your roots, right? Or your what? Solutions. So whenever they ask you to solve a quadratic function, we're trying to figure out, okay, what am I looking for? Because anytime you solve something, you're looking for the solutions, right? So what is the solution to a quadratic function? It is actually your zeros. All these key features we got, concavity, shift, max, min, vertex, all those things can help us figure out things in real world context. But if they say solve this quadratic function, they are looking for the x-intercepts. Now everything we've done has not been focused on the x-intercepts. They've been focused on all the other key features. But when we graph them, sometimes we're able to see the x-intercepts, aren't we? Yes?
Yes.
In our foursquare, won't we able to see where it hits the ground? Yes? So we're able to see x-intercepts, but they're not always clear. I'm going to wait because I'm distracted. So we're always looking for the zeros, the solutions, the x-intercepts, the roots. So next week, that's the only focus. It is, how do I find these solutions mathematically? Are y'all with me? And then once we get those, now we can take it back to real world to figure out different things about using a parabola, right? See what a parabola can show us in real world context. So what are the methods that we use for solving? This is not finding the key features. What methods do we use to solve, to find the zeros? There are different methods. They are listed. We talked about these at the very beginning. What are these methods? I can use a table. I can, which we've already done, right? How to graph. I can use the graph, but sometimes the graph isn't always clear. Because remember last week we had a problem, and when we graphed it, we couldn't really tell exactly where it fell, right? Because it was between two numbers. So sometimes that don't always work. So now we got to look for another method. What could that other method be? Factoring, which we're going to play with next week. And remember when I showed y'all the four squares?
Yes.
We're going to use those four squares to help us with factoring. And then what else we got? Quadratic formula or completing the square. So what I'm going to show you right now, because I want to show you one thing before we move on today. I want to show you solving with quadratic formula. And the reason I'm showing you is because quadratic formula is the easiest method for finding the solutions. And why am I saying that? Because it's always a go-to. The formula, back in the day, you used to have to memorize the formula. I had to make sure my kids knew it because it wasn't on a reference sheet. But you all don't have to memorize it. So it don't take us as much time because we ain't got to learn the formula. It's on the reference sheet and it's in the classroom. If y'all look right up here to the top, y'all see it?
Yes.
Right? That's the quadratic formula, right? Now, what do you need for the quadratic formula? you need a what?
A,
A, B, and a what? C. That's all it's asking for. We know what a 4 is. We know what a 2 is. So it's just asking us for A's, B's, and what? C's. Do we know how to identify A's, B's, and C's from a quadratic function? Yes. So as long as you got that, you can use that formula. Are y'all with me? And we know the order of operations, right? We got to do grouping symbols first. Grouping symbols are parentheses or square root symbol, right? A radical is also considered a grouping symbol. You got to simplify that. After you do your grouping symbols or your parentheses, then we do what? What's after P?
Exponents.
Exponents. Then once you do your exponents, you do your what? Multiplication or division from what? Left to right. Then after that, you do what?
Addition
And subtraction. Y'all don't forget, please excuse my dear Aunt Sally?
No.
Y'all ain't never learned that?
I did.
PEMDAS?
I know.
We never learned that? Oh, come on. Are you kidding me? I know your teachers taught you that.
P's is used by their
Y'all never learned that?
yes.
Yes? Parentheses,
exponents, multiplication,
exponents, multiplication, and what? Division. But these go from left to what?
Right.
And then addition and subtraction. These also go from left to right. They like twins. You can't just always do multiplication first. It's whichever one comes first, that's the one you go to first. Are y'all with me? But this is PEMDAS, right? So we use this order of operations. It tells you the order in which you complete operations. Addition, subtraction, multiplication, division. Right? So that everybody ends up with the same answer if you follow the order of operations. Distraction. So come back. I want to show you the quadratic formula for this problem so you can see the solutions. And then we're going to write the rule in which form of a function can we quickly see our solutions? Which form? Is it standard form? Do you see your solutions in standard form? Do you see your solutions in vertex form? Do you see your solutions in factor form? Which one? What are solutions? What are the solutions to a quadratic function? It's your x-intercept. So which one do you see x-intercepts in? Factor. So factored form, if I give you solutions, you should be able to write a rule for me in factored form. If I give you factored form, you should be able to pull from factored form your solutions, right? All right, let's do it real quick. Everybody's working with me. New page. Very next page. Hurry up, because I want to give you as much time on your quiz.
Please.
Will we skip?
Everybody got calculators out in front, ready to go? All right, so let's go. All right, what is the quadratic formula? It is a method that I can use to find the solutions, the x-intercepts, the zeros, the roots of a quadratic function. Is everybody with me? All right, so let's go. Formula is negative b plus or minus. What does that mean?
Plus or minus.
How many answers I'm going to get from this? 2. Because aren't I going to add something and then subtract it? And isn't that going to give me 2 different things? If I take 5 and add 3, I'm going to get 8. If I take 5 and subtract 3, I'm going to get 2. That's going to give me 2 different answers. So this is what helps us to get those 2 intercepts. Matter of fact, let me show you this real quick. What if I had... How many solutions? 1. How you know that? It hits the x-axis once. And what are the solutions to a quadratic function? X-intercepts. How many x-intercepts are here? One. What about here? One. How many times does it hit this x-axis? Once. So you only got one x-intercept for this one. I'm not talking about the two together. It's how many are here, right? What if I gave you this? How many? Two. Right? What about if we went the other way, right? And went this way? How many? Two. So if I'm solving this quadratic formula and I end up with one answer, two answers are exactly the same, like I get 5 and 5 or 3 and 3 or 2 and 2, then that means I'm talking about one solution. Are y'all with me? If I do it and I get like 2 and 8, right? Or 3 and 7, right? Then that's two different intercepts. Are y'all following me? Right? What else could I possibly see? I could see this. What is that? No solutions. Why? It ain't touching the x-axis. What about this one? No solution. If my max is a negative number and A is negative and it's going down, then that means this thing is heading down. It ain't gonna hit the x-axis. Are y'all with me? If my max is a positive number, like let's say this is a 2, and then it's a positive A, then that means it ain't gonna never touch the x-axis because it's above, it starts above and it goes up. Are y'all with me? So how many solutions do we have? None. Not 0, because 0 is a possible solution, right? But this is no solutions. It ain't no solutions. Are y'all following me? So can I have 3 solutions? No, this thing don't U back through here, right? It's a U. So you're going to either have one solution, you're going to have 2 solutions, or you can have what? No solutions. Question. Before we start, we already started. All right, here we go. Negative b plus or minus. Give me the rest. The square root of what? B squared minus 4 times A times C. All over 2 times A. Do we all understand that this is multiplication in here? Yes? So you got the opposite of b plus or minus the square root of b to the second power. And then you take away from that the 4 times the A times the C. And you put that all over 2A. Now let's do it with this problem real quick and see what we get. Y'all with me? All right, let's go quickly. What we got?
Negative 15.
Negative.
Positive.
What am I putting here?
Negative 15.
Negative 15. Thank you, sir. Plus or minus the square root of what?
Negative 15.
Negative 15. What I'm doing with that?
Squared.
Square. Minus 4 times 1 times
36.
36. Everybody know where we getting these numbers from, right? Now watch this. This can take up a lot of paper, right? Because look at it vertically. It can take up a lot of paper. So what I tend to do is I like to do it horizontally. So I'm going to show you what I'm going to do. Watch this. All over 2 times, what's our A? 1. Notice what I'm doing. Instead of it being at the bottom, I'm putting it on the side. Why am I doing that? So I can take, so I don't take up a lot of space, so I can save space, right? All right, does everybody understand why I'm doing that? But this just means division. So you got to do this part first, and then you divide by that. Are we all clear? Yes? I got a boogie in my nose or something?
No.
I'm just trying to figure out all the giggles that's happening around the room. Okay. What is the opposite of negative 15? Positive 15. Plus or minus the square root of what? What do I have? What is negative 15 squared? Y'all got the calculator. Why y'all trying to pull it out your brain? Let's go. What's 15 negative squared? Negative 15 squared. Positive 200 what? 25. Now, do not bring this negative down. Don't. Why? Because this don't always mean that's what the sign go here. Right? It depends on what's happening. Because isn't this multiplication? So you got to multiply before you put your addition or subtraction sign. So let's look. If there's one negative, answer's going to be what? Negative. What if there was 2 negatives? If this was negative and this was negative, then it would be what? Positive. What if this was negative, and this was negative? No.
Negative.
3 negatives means this time this going to give you a positive, but this third one going to make it what? Negative. So if you got an odd number of negatives, then your answer is going to be what? Negative. How many negatives do I have here?
1.
So is my answer going to be positive or negative?
Positive.
Positive.
How many negatives does it take to make a positive?
Or.
2. How many do I have? 1.
So we.
Okay. I do this class a little different. It's okay. Grab your calculators. Let's go. Because that method ain't working. Let's put in our calculators. What is this number?
Negative 4.
Okay, let's put 4 plus or minus. 4 plus or minus. Right? Then we're going to do what? Times 1. Times 1. Then we're going to do what?
Times 36.
Times 36. And equals. What does that give us?
Negative.
That's when I put the sign down. Are y'all with me? So this is going to be negative 144. Everybody got it? Yes? No?
Yeah.
Negative 144. How did we get that? Just from multiplying those things. That's it. Now that's going to be all over, what's 2 times 1? 2. I got 3 minutes. Let's go. Is everybody following? Yes. All right. Now, what's my next line going to be? Can I do anything with this 15 yet? No. So again, 15 plus or minus?
Square root.
The square root. Thank you. What's 225 minus 144? I shouldn't be waiting for these answers. 81. All over what? 2. Notice this 2 just hanging along until I'm done with the top. Are y'all with me? All right, so now let's keep going. What I got next? 15 plus or minus. I cannot do any adding until I'm done with this. What is the square root of 81? What number times itself give you 81? 9. If we don't know that, then we can just come over here and put what in? 81. And then we hit right here. Square root, radical. And we get what? 9. So this is going to be whole number 9. All over what? 2. Is everybody with me? Now it's simplified. I don't have any more grouping symbols. Now I'm ready to roll. Are y'all with me? What did we say that plus or minus is doing for you? It's going to give you what? 2 different answers. So guess what? I'm going to break this up. This is a key part. This is the part where I break it up. Everything is simplified. Radical is gone. Now I'm going to break it up to 2 parts. What are those 2 parts going to be? 15 plus 9 over what? 2. And then what? 15 minus 9 over what? 2. Is everybody with me? Yes? What is 15 plus 9?
20. 24.
24 over what? 2. And what's 24 divided by 2?
12.
12. So this first one is x equals what? 12. What does that mean? What is this? That's one of my roots. That's one of my x-intercepts. That's one of my x-intercepts, right? What am I going to do for this one?
You're going to do 15 minus 9.
What we get?
6.
6. And put it over what?
2.
2. So now 6 divided by 2?
3.
So this one's going to be x equals what? 3. So how many solutions do I have to this problem? 2. What are my 2 solutions?
12 and 3.
12 and 3. Are you guys with me? And let me show you something real quick. In your calculator, I'm just going to show you this really briefly because I'm ready to stop. In your calculator, do this for me. Put 12.
12.
You take in one root. Plus 3, which is your other root. And divide it by, put equals, sorry. 12 plus 3 equals. And then divide by 2.
7.5.
What was 7.5?
X to the vertex.
It was the x of the vertex. It was also your what? It was your AOS. It was your axis of symmetry. So watch this. If it's your axis of symmetry, what does your axis of symmetry do? Don't it divide your parabola in half?
Yes.
Yes? How far? Matter of fact, let me just do it like this. Watch this. You got, watch this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3. First 0. 12. Other 0. What number did you just give me? When you add and divide by 2, what you got? When you add and divide it by 2, what you get? 7.5. 1, 2, 3, 4, 5, 6, 7, 8. 7.5 is right here. So guess what's right here? Axis of symmetry. How far is this from here? 1, 2, 3, 4.5. Y'all see that? How far is this? 1, 2, 3, 4.5. It's right smack dead where? In the middle. So your parabola is going to U up just like this, and your vertex is going to be somewhere here. Are y'all following me? Does that make sense? Yes? All right. So how else can I find my axis of symmetry? If I got my zeros,
The distance between them.
the distance between them. I got to see what that midpoint is between them. And how do I get that? Add them together and divide by what? 2, and that'll give me the spot right in the middle. And that will give me my axis of symmetry if I have factor form. So that's the last thing we're going to write. What is factor form of a function?
Y equals
Thank you. Y equals A times
X minus P
X minus P times,
X minus Q.
where P and Q are your roots. What were our roots that we just found?
3 and 12.
12 and 3. So help me out. Y equals, what was our A?
Y equals 1.
What was that? 1 times X minus X minus. What was this one?
12.
12. And what's this one?
3.
3. Nikala?
Is that a P?
P and Q. Everybody good here? This is what form? Factor form. And what do we always say? When you're giving factor form, don't you pull out the opposite of what you see? Yes, because they're following minuses. Are y'all with me? So if you see a negative, you pull out a positive. If you see a positive, you pull out a what? Negative. But this is how we write factor form. These are our solutions. Everybody good there? Yes, great. Clear your desk and everything.
The question. Does it matter the order in factor form?
Does it matter what?
The order in factor form?